I've always been interested in airplanes. Owning an airplane and having a passion for aerospace actually gives you almost instant credibility with an aerospace customer. And when you bring an aircraft approach to the space industry, it's a big win for them. SDA is primarily a services company. We provide structural analysis services to the aerospace and other industries. I founded the company because I had worked for a number of companies in my career. I didn't like being limited by what those companies were working on. Working on the Orion project started with a program called the Composite Crew Module. The NASA administrator wanted to study why weren't composites used. So he handpicked a team to design a composite crew module. We designed it, we built it, we tested it all the way to failure. Our weight was extremely competitive with the aluminum design, and it was that got SDA noticed by Orion. Later, we were asked to study the heat shield. We were picked to technically lead that team because we were composite experts, and the Orion heat shield is made out of composite. Our team was responsible for building the finite element models, running the trade studies to determine what other architectures could make the structure lighter, and then doing the detailed analysis of that new architecture to determine how light it could be, how thick everything needed to be, what the spacing was.
Overall, the challenge in meshing is how do you turn a structure into a highly detailed mesh. In this case, it was 250,000 elements that we had to create. And what Femap brings to the table is a lot of built-in features that help you expedite the process of creating high-quality elements.
Femap allowed us to build a very detailed model very quickly.
The challenge of the Orion Heat Shield mass reduction project was to look at the original design and come up with a way to save 25% on the original baseline mass of that structure. Over the course of that project, we were able to attain a 50% mass savings over the original design.
Our goal was 800 pounds. We ended up achieving close to 1,500 pounds of weight savings.
What made the OrthoGrid the best design at the end of the day was the uniformity and the stiffness it provides to the structure. And that's something we were able to uncover with simulations using Femap and NX Nastran. One of the big benefits of Femap is its API programming capability. And through the API, we're able to link that to Microsoft Excel and use all the benefits of Excel with the benefits of Femap. Having Femap allows you to have one cohesive and familiar interface for exporting analyses to those different solvers. Femap is the predominant modeling and post-processing environment for people in the aerospace industry. It's the one single solution for creating the model.
The heat shield program for us was a large stepping stone. Now we are supporting NASA on the WFIRST program, which is a wide field infrared space telescope. We are Femap experts, and it's that expertise that is getting customers to know us. I feel like I have a lot of knowledge. I would like to give that knowledge to a larger group of people so that it can benefit more programs. I'm trying to bring the next generation up to know how to do the analysis appropriately to get the best structure. When you can work on the Orion space capsule and on a large telescope at the same time, and on some general aviation airplanes and on UAVs, and you can do it all in your first year, it's a pretty cool place to work.